Hello everyone, welcome to the lecture again. In the last class, we discussed about the direct central impact wherein the direction of the motion of the particles were along the same line, that was the line of the impact. Today, we are going to discuss the oblique central impact wherein the direction of motion of the particle is at an angle to the line of impact. So, therefore, the situation is following. We have particles, let us say two particles, and they are moving like this. So, this is the particle A, its velocity is let us say like this, and then we have another particle B, and let us say it is moving like that. Okay. So, the common tangent is this, and the line of impact is like that. Let us call this direction as n, and this is the line of impact. This is the tangent. So, let us call it t direction, and this is the tangent to the contacting surface. And what we want to find out is, after the impact, what is the velocity of particle A and B, and at what angle they are going. So, basically we need 4 equations because there are 4 unknown: velocity and the angle of both the particles. So, 4 unknown, therefore, we need 4 equations. Okay. Now, in the n direction, so that is along the line of the impact, the impulse act, but for the whole system the impulse are equal and opposite. Therefore, the conservation of total momentum will hold. Okay. So, we are talking about the n direction. So, let us apply the conservation of angular momentum for the whole system. So, initial velocity is V A, mass is let us say m A, and this has a mass of m B. So, we have m A V A. Note that it holds only in the n direction. So, let me write down n here. So, that means the velocity of particle A in n direction plus m B V B in the n direction equal to m A. Let us say after the impact the velocity becomes V B prime and V A prime. Okay. So, we have m A V A prime in the direction n, and m B V B prime in the direction n. Let us call it equation number 1. Similarly, we have the definition of E, which is the relative velocity of separation divided by the relative velocity of approach, that will also hold in the n direction. So, we have relative velocity of separation divided by the relative velocity of approach that will hold in the n direction. So, this will be equal to V b prime n minus V a prime n divided by V a n minus V b n. Let us call this equation number 2. Now, in the t direction, that is in the direction of tangent to the contacting surface, there is no impulse. So, if the impulse is not there, then the momentum of both the particles will be conserved separately. So, we have no impulse. Therefore, the momentum of each particle is conserved in the t direction. Okay. So, we have mass m a v a in the t direction. This is the initial momentum of particle A equal to the final momentum of particle A. So, m a v a prime t. Okay. So, m a will get cancelled and this will give you v a t equal to v a prime t. So, let us call this equation number 3. Similarly, for particle B also the momentum will conserve in the t direction. So, we have m b v b in the t direction, this is the initial moment equal to the final moment in the t direction. So, m b will get cancelled. So, we have v b t equal to v b prime t. Let us call it equation number 4. So, now we have 4 equation and as I said there are 4 unknown. So, in principle the problem can be solved mathematically. Now, let us look at some of the examples based on this concept. This is the first problem statement. A ball is projected onto the heavy plate with a velocity of 16 meter per second at the 30-degree angle as shown. If the effective coefficient of restitution is 0.5, compute the rebound velocity v prime and its angle theta prime. So, clearly this is the example of oblique angle impact and we have to find out what is the rebound velocity v prime and what is the angle theta prime. It is also given that the plate is heavy. So, therefore, this plate does not move during the impact. Let us use the definition of E. So, E is relative velocity of separation divided by the relative velocity of approach. Okay. And this holds in the n direction. So, let us find out what is the relative velocity of separation and approach in the n direction. So, E is v2 prime in the n direction minus v1 prime in the n direction divided by v1 n minus v2 n. Okay. So, this is in n direction. Okay. So, v2 is or v2 prime or v2 is 0 because the plate is heavy, it does not move, minus v1 prime n divided by V1 n. So, V1 n is the velocity of particle 1 in the n direction before the impact. So, it is minus 16 sin 30 degree and V2 n is 0. Okay. And it is given that this is equal to E and the value of E is 0.5. So, from here I can find out what is V1 prime n, and V1 prime n comes out to be 4 meter per second. Okay. Now, in the t direction, the conservation of momentum of particle A holds. So, in the t direction, the momentum conservation of, let us say, ball 1 holds. Therefore, we have m v1 in the t direction, t equal to m v1 prime t, and m will get cancelled. So, we have v1 t equal to v1 prime t. Now, v1 t we can know from the diagram. V1 t is 16 cos 30 degree equal to V1 prime t, and 16 cos 30 degree is 13.86 meter per second. So, we know what is V1 prime n and what is V1 prime t, therefore, I can calculate what is V1 prime. So, V1 prime will be square root V1 prime n square plus V1 prime t square. So, that will be square root 4 square plus 13.86 square, and that will be 14.42 meter per second. Now, let us calculate the angle theta prime. So, tan theta prime will be V1 prime n divided by V1 prime t. Now, V1 prime n is 4 and V1 prime t is 14.42, therefore, theta prime comes out to be 16.10 degree. Now, let us look at another problem statement. The magnitude and direction of the velocities of two identical frictionless balls are shown before they strike each other. Assuming E equal to 0.90, determine the magnitude and direction of the velocity of each ball after the impact. Okay. So, the situation is following: we have ball A and its mass is m, and it is moving with velocity V A equal to 9 meter per second, and it makes an angle of 30 degree. Then we have ball B, its mass is also m because the balls are identical, and velocity of B is 12 meter per second, and it makes an angle of 60 degree from the horizontal. And we have been asked to find out the velocity and direction of each balls after the impact. So, this is the common tangent to it. Let us take it as plus t direction, and this is the line of the impact. So, let us take it as plus n direction. Now, we can from the component we can find out the initial velocities of particle A and B in the t and n direction. So, let us see V A in the n direction is 9 cos 30 degree. So, that is 7.79 meter per second. Velocity of ball A or particle A in the t direction is 9 sin 30 degree. So, that is 4.5 meter per second. For particle B or ball B, VB in the n direction will be minus 12 cos 60 degree, which is minus 6 meter per second, and VBT will be 12 sin 60 degree. So, that is 10.39 meter per second. Now, let us use the definition of E. So, E is the velocity of separation divided by the relative velocity of approach. So, it is VB prime n minus VA prime n divided by VA n minus VB n. Okay. And E is given. So, E is 0.9 equal to VB prime n minus VA prime n divided by VAN, and VBN we already know. So, it is 7.79 minus 6. So, that becomes plus 6. So, that gives you VB prime n minus VA prime n equal to 12.41. Let us call it equation number 1. Now, the total momentum will be conserved in the n direction. So, therefore, we have m VA n plus m VB n equal to m VA prime n plus m VB prime n. Now, m will get cancelled because the masses are identical. So, we have 7.79 minus 6 equal to VA prime n plus VB prime n, or I can just rewrite this as VA prime n plus VB prime n equal to 1.79. Let us call it equation number 2, and from 1 and 2 you can find out what is VA prime and what is VB prime. So, from 1 and 2 I get VA prime n equal to minus 5.31 meter per second and VB prime n equal to 7.1 meter per second. Now, in the t direction, as we have discussed, the momentum of each particle will be conserved. So, we have momentum conservation of each particle in the t direction. Okay. So, we have VAT equal to VA prime t because m will get cancelled. So, therefore, we have VA prime t equal to VAT we already know, it is 4.5 meter per second, and similarly VBT equal to VB prime t, again m will get cancelled. So, we have VB prime t equal to VBT, which is again we know it is 10.39. So, this is 10.39 0.39 meter per second. And from here I can find out what is V A prime. So, V A prime will be square root V A prime n square plus V A prime t square, and that will be 6.96 meter per second. Now, the angle alpha that particle A makes after the impact can be found out by using tan alpha equal to V A prime n divided by V A prime t. So, angle alpha comes out to be 40.3 degree. Okay. And V B prime, that is the velocity of particle B after the impact, is square root V B prime n square plus V B prime t square. So, that will be 12.58 meter per second, and the angle that it makes from the horizontal can be find out again by taking tan beta equal to V B prime n divided by V B prime t. So, beta comes out to be 55.6 degree. So, using these 4 equations we have calculated the velocity and the direction of particle A and B after the impact. Now, let us look at another problem statement. A spherical particle one has a velocity V1 equal to 6 meter per second in the direction shown, and collides with a spherical particle 2 of equal mass and diameter and initially at rest. Okay. If the coefficient of restitution for these condition is E equal to 0.6, determine the resulting motion of each particle following impact. Also calculate the percentage loss of energy due to the impact. So, let us analyze this. We have particle 2 and particle 1. The outer surface of particle 2 is aligned with the center of particle 1. Particle 1 is moving with a velocity of 6 meter per second. So, during the impact we will have particle 2 and particle 1 like that. The center to center distance should be 2 times r. Okay. So, this distance is 2 times r if r is the radius of the particle or the sphere, and since this is r, therefore, I can find out what is this angle theta. So, from the geometry you can see that sin theta should be r over 2 r, therefore, theta should be 30 degree. Now, the common tangent is this, and the line of impact is that. So, therefore, let me take this as plus n and this one as plus t direction. Let us find out the velocity of a spherical particle 1 and 2 along the t and n direction. Since theta is 30 degree, therefore, v1n will be v1, which is 6 meter per second cos 30 degree. So, that will be 5.2 meter per second, and v1t from the geometry it will be v1 sin 30 degree, that will be 3 meter per second, and since particle 2 is at rest, therefore, v2 n will be 0 and v2t will also be 0. Here it is given that m1 is equal to m2, and we know that the conservation of momentum for the whole system will be valid in the n direction. So, let us apply the conservation of momentum of the whole system in n direction, and m1 equal to m2, they said it is given. So, therefore, m into v, but m will get cancelled. So, we have 5.2 in the n direction, the velocity of particle 1 plus 0 equal to v1 prime n plus v2 prime n. Let us call it equation number 1. Now, also in the n direction we have E equal to v2 prime n minus v1 prime n divided by v2 n minus v1 n. So, E is given, it is 0.6 equal to v2 prime n minus v1 prime n over 5.2. Let us call it equation number 2, and from equation number 1 and 2 we can find out both the unknowns, that is v1 prime n and v2 prime n, and it comes out to be 1.039 meter per second and v2 n comes out to be 4.16 meter per second. Now, the conservation of momentum for each particle will hold in the t direction. So, conservation of momentum for each particle will hold in t direction. So, since the masses are equal, so m will get cancelled. So, v1 prime t equal to v1 t, and v1 t is already known. So, therefore, v1 prime t becomes 3 meter per second, and v2 prime t equal to v2 t, and v2 t is 0. So, therefore, this is 0. So, from here I can find out the magnitude of v1 prime and the direction of v1. So, the magnitude is square root v1 prime t square plus v1 prime n square. So, v1 prime becomes square root v1 prime n is 1.039 and v1 prime t is 3. So, therefore, it is square root 1.039 square plus 3 square. So, that is 3.17 meter per second, and the angle alpha will be tan inverse 1.039 divided by 3. So, from here you get alpha equal to 19.11 degree. Okay. Similarly, V2 prime will be square root V2 prime n square plus V2 prime t square. So, square root 4.16 square plus 0 square. So, square will get cancelled with the square root. So, we have 4.16 meter per second, and the angle beta will be tan inverse 4.16 divided by 0. So, that will be 90 degree. Okay. So, the situation will be like that. So, we had this particle there, and then this one here. After the impact, so this is our common tangent, this is the line of impact, this is beta degree. So, therefore, particle 2 will move with a velocity of V2 prime in that direction, and particle 1 will go in a direction alpha with a velocity of V1 prime, okay, where alpha is 19.11 degree. Now, let us calculate the percentage loss in the energy. So, here the energy is the kinetic energy. So, let us find out what is T initial. The initial kinetic energy, it is half m1 v1 square plus half m2 v2 square, and v2 was initially 0 and m1 is equal to m. So, let me put m1 equal to m2 equal to m, because both of them has the same mass. So, that comes out to be 18 m, okay, where m is the mass, and T final comes out to be half m1 v1 prime square plus half m2 v2 prime square, and you know the values of v1 prime and v2 prime you can put, and m1 equal to m2 equal to m. So, that comes out to be 13.68 m. So, therefore, the percentage change in the kinetic energy is T initial minus T final divided by T initial multiplied by 100. Okay. So, you know the T initial and T final. So, that comes out to be 24%. With this, let me stop here. See you in the next class. Thank you.